Hi, for question 8, the diagram shows an incomplete series circuit. We have the battery, ammeter, and lamp. For section A, draw a thermistor to complete the electric circuit. So here I draw this box or rectangular shape, which is for resistor. But when you draw the arrow like this, now this is what we call it in physics, which is thermistor. I add a voltmeter to the circuit to measure the voltage across the lamp. So you draw the voltmeter like this, parallel to the lamp. For section B, the voltmeter measures a voltage which is 5.6 volt, this one for the voltage across the lamp, and the electric current 790 milliampere. The question is, how can I write or state a linking equation, voltage, current, and resistance? V, which is voltage, I times R. V, which is voltage, I for the electric current, and R, which is resistance. Shall I rearrange the equation? Definitely, R equals V over I. Can be accepted. I equals V over R. Any form of these three equations accepted. For section or double I, now the examiner tried to asking for applying the mathematical formula, so resistance, which is V voltage over I, resistance of the lamp. But there is one thing here, which is in section B, that the current was given as 790 milliampere. So the current must be given into ampere, which is 10 minus 3 ampere. I make changes and I get 1 mark for the rearrangement and 1 mark for definitely the changes, the electric current into ampere. Then now you substitute how much is the resistance. R equals V, which is how much is the voltage in the previous 5.6 volt, divided by 0.79, which is ampere. And the answer for this one, which is 7.91 ohm, which is approximately, the examiner gave a lot of options, like 7.089 or 7.0886. So 7.1 accepted as well. Two significant figures. So we get 3 marks for double I. For section C is quite challenging. The completed circuit is moved from a cold room to a hot room. Explain how this would affect the brightness of the lamp. By the way, the lamp is connected in series with the thermistor. This question is targeting 3 marks. So think about the thermistor itself. So as the temperature, this is the keyword, really important, of this room, you would say increases. So as a result, what do you think? Because thermistor is a non-metallic material and doesn't obey Ohm's law. So there is a kind of change in the IV characteristics. So as a result, the resistance of thermistor here is going to be quite different. So the resistance here of the thermistor decreases. That's cool. So R of the thermistor decreases. Okay. So what should I say? So the total resistance here, which is the series for both lamp and the thermistor, here decreases. Good. And I know the formula here, which is the total voltage equals to the total current and the total resistance. And let me use the mathematical formula. So if the R total here decreases and the total voltage is constant, so inversely proportional, so as a result, there is an increase in the total electric current in the electric circuit. So the total current here in series circuit increases. So I increases. Okay. Or I would say the voltage across the lamp, only the voltage across the lamp would increase, because the voltage on the which is across the thermistor will go down. So I deserve 3 marks. I would say it again here. As the temperature increases, resistance of thermistor decreases, total resistance decreases, total current in the series circuit increases. But I forget to mention one key word, which is what would happen to the brightness of the lamp. Definitely the brightness of the lamp would increase. So the brightness here finally increases. I get 3 marks for section C. For section D, state how the current in the circuit would change if another lamp is added in series with the first lamp. So if another lamp, so here I have to think about the V total equals to the I total and R total. If you connect another lamp in series, so in series, the R total is going to be R of the lamp 1 plus the resistance of the lamp 2. And did you realize they are in series? So I'm adding the resistance, so the total resistance will be increased. So definitely this one affecting on the electric current. So the electric current will decrease, or will be it decreases or will be halved if we use the same resistance or the same value of resistance of the new lamp or the second lamp or the other lamp. So I get full mark here in the question 8, 11 out of 11. See you next video, guys.